So what I'm doing here is I'm also giving you the answers on the top. The answer to this question. You can compare your assignments, right? The answer to this question is this, but let's solve this and see if intuitively how do we get there, right? Okay, first, what is the question? Find VC of t for t greater than 0 in the circuit below, right? So what is VC of t? VC of t is the voltage across the capacitance. So when you initially the t is connected to switch and you are turning it off, you are really turning it off. When you say this, right, it just means that at t equal 0 you are connected. Just after t equal 0 you turn it off. So the switch is now brought here. So this means the switch is disconnected. Okay. So what we are asked to do is find out VC of t. Apply first principles before the switch turns off, right? What is the voltage across the capacitor? Why 12 volts? What is the circuit before the capacitor turns on? It is
short circuit. Capacitor is short circuit.
Capacitor short circuit, understood. But now what is the voltage across this? This is 12 volt. There's 3 kilo ohm.
Yeah.
There is 4 kilo ohm and there is 2 kilo ohm, right? 2K, 4K and 3K. By the way, I have not solved it myself, so I want to solve it now along with you, right? So that we understand how this is, right? Okay. Now, what is VC of t? VC of t is this voltage. This is the voltage. Okay. So is 4K and 2K in series? So can I replace this entire thing as a 6K? Okay. So now, what is the voltage across 6K? 6K by 6K plus 3K. So 9K into 12 volt. Correct? Yes or no? Yeah. So this is 2 by 3 into 12. So roughly around 8 volt. So was it Kavya? Kavya, do you agree that this is 8 volts and not 12 volts? Okay. So you already know that your capacitor started with, even before your switch is on, right? Your capacitor started with 8 volts. So switch is off, right? This is 8 volts. So what is VO, right? Just as a vanity check. What is VO? VO is nothing but it's a voltage divider. 2 kilo ohm and a 4 kilo ohm. 2 by 6 into 8 volts. So 1 by 3, roughly 8 by 3. 8 by 3 volt. Clear? Okay. So capacitor is starting at 8 volt. It was there at 8 volt, fully charged at 8 volts, waiting for something to happen. Now the switch is turned off. Okay. So it's a very simple discharge problem. Okay. What is the discharge problem? You have 8 volts capacitor, and what will be the final voltage across the cap? What is the final voltage across the cap? Capacitor. What will happen to the 8 volt? The resistor will discharge completely. Right now, ultimately, the capacitor will be left with nothing. See, keep in mind, capacitor either gets charged or either gets discharged, right? It's either charged. If there is a voltage source, then it gets charged to that voltage source. Effective voltage on that net. If no voltage source is there, capacitor will die down to 0. Whatever be the network that is connected, right? It dissipates because any non-zero voltage across the cap will still induce current. Now, all that effective resistor that you have across the capacitor will still carry a current, which is voltage of the cap divided by R effective, right? So this means there is still some charge. It will keep discharging and ultimately it should go to 0 only. So what is your voltage on the cap at t equal to plus infinity? So it starts at 8 volts.
0.
It goes to 0. What is the time constant of the cap? RC. What is the time constant? Now tell me, what is R effective?
6.
6 kilo ohms. 6 kilo. What is R effective? It is 6 kilo ohms. Why? For this thing, it's a series. 4 kilo ohm and 2 kilo ohm are in series, right? So 6 kilo ohms multiplied by the capacitance by
6 micro.
Correct. Into 10 power minus 6. This is kilo, that is this. So you end up with roughly around 0.6. 0.6. So now blindly can I say the voltage across cap is initial condition 8 volt into e power minus t by RC tau, right? This is 0.6 volts. That's it. That is your answer. Agree? Everybody agrees to this? So is this clear? I mean, again, no differential equation. No differential equation, nothing. You are remembering the solution to the differential equation, right? It's a e power minus t by tau. This is what you are remembering. Calculate initial condition, calculate final condition, estimate your time constant. That is important. Correctly estimating the time constant. And how do you do it? Find out what are the series resistors, find out what are the parallel resistors, right? And R effective into C is your time constant, e power minus t by tau. Put it, get it, and very simple thing. So normally this question should, if you are clear, right? If your concepts are clear, this should not take you more than 1 minute to solve, provided you are clear in the concept. Okay, agree? So don't get scared when you see, okay, switch is going here, there, okay, whatever, let them say, let them ask whatever they want, right? Stick to fundamental principles. Find out what happens before the switch is turning off, calculate everything, go with your concept. Cap is an open circuit impedance, it's an open circuit, so that voltage must be a simple resistor divider. Okay, you have it on the cap, voltage cannot change instantaneously, so it will start from that same voltage and will discharge. Okay, clear everybody? First problem is clear.